Children, listen. Today we are going to start chapter number 6, application of derivatives. In that main topic, what na? Rate of change of quantities. What is that? Rate of change of quantities we are going to see now. Generally, rate of change of quantities in the sense, what is that? Some variable going to change about another variable. Okay, going to change with respect to another variable. That means this is going to change. This is going y changes with respect to x, which means what we will be telling dy divided by dx. So that changes or rate of changes are what is that increasing, decreasing, like that word and all they will be using for a differentiate word. Okay, so rate of change means we are differentiating with respect to what they are mentioning. That rate of change of quantity means a quantity is a y, the y variable going to change with respect to some other variable. Understand, that is the meaning for the rate of change. So rate of change in the sense simply it means that differentiate, derivative of the quantity, you can realize. Understand, right? What I'm going to take, suppose if I'm taking let y equal to f of x, I'm taking that f of x we are going to represent in the form of dy by dx. Now how you will be writing? Then y, if I'm doing differentiate with respect to x, na, what is that? Dy divided by dx or f dash of x also we will be telling. Okay, this represents what it mean in the sense this represent the topic. Okay, this represent the topic, that is I'm going to say. So that what is that represent? So this represents the what? Rate of change of y, rate of change of y with respect to x. That is the meaning, rate of change of quantity. Okay, right. So that we can write with respect to some variable also. Here actually x value and all they will be giving and here I said with respect to x. Sometime with respect to x naught means the x value they will be giving something. X naught can be any number, any real number they will be giving. That also you can apply. For example, and x is equal to x naught if I'm taking now. X naught if I'm taking now, then what I'm getting f dash of x naught or dy divided by dx. This is called at x naught. Okay, x is equal to x naught. Okay, so listen carefully. This bracket you want to say what now? At dy by dx at x equal to x naught. You want to read like that. Understand? Dy divided by dx at x is equal to x naught. Like that you want to read. At the bracket you want to consider as a at. Understand? Like that they will be doing. Right. Based on this, we know some chain rule and all we are using. Suppose double variables, if we have this, point number 1 will take. Suppose point number 2, let x is equal to f of t we have, and y is equal to one more function. What is that? G of t if you have na. If you want to find dy by dx now, what you will be doing? So that we will be doing dx divided by dt when you differentiate that f of t here. Like that dy divided by dt which is equal to g dash of t. Then if you want to find dy by dx, we know very well, we have used in 5th chapter these things. Dy divided by dt whole divided by dx divided by dt, or in simple manner g dash of t divided by f dash of t also you can use. What is that? F dash of t also we can mention. This is by using chain rule we can go. Understand? Or else directly if you are doing also, right, fine. Right, this is the introduction. Means the word rate of change now you have to differentiate. Okay, increasing, decreasing also you can use. Increasing na positive symbol you should use ma. Decrease na negative symbol you should use. Then third point you take. Okay, dy by dx is positive. Is positive na. What we have to say? Y increases as x. We have to say. Okay. When it will be positive? If okay, if what is that? Y increases as x. Okay, y is increasing as x increases. So this is the, if this is true na, dy by dx is positive. Okay, and suppose negative, dy by dx is negative. Dy by dx is negative na, if y decreases as x increases, opposite. Okay, if what is that, y decreases as x increases. Understand? So this is opposite. When one term will be increases, another will be decreases. Like that na, we have to use a negative. Okay, that is very important point. Okay, these three things just remember pa. Then we'll enter in the sum. And before goes to exercise, one increases, other will be decreases. First point, both will be increases. First point, y increases as x also increases na, that will be positive. Now we'll go to the some actually we can go, the introduction is enough for the exercise, but we need some previously whatever you have studied, everything we have to revise, because the formulas we are going to use it. So let's revise that. Listen, the formulas which I will give. First about 2D I will give. Area, listen children, area about circle. Circle, if I am taking na, what? Circle. What is that area of circle pa? What is area of circle ma? Area of circle is what pa? Pi r square. Area of circle, pi r square. And what about circumference? Very good. Okay, circumference is equal to 2 pi r. This is the, okay, circle. And next rectangle, if I go. Rectangle also we will be using. Then area of rectangle what pa? Area is equal to length into breadth. So circle here, circle if you are drawing na, that will be radius. Rectangle if you are drawing na, this will be length, that will be breadth. Okay. And what about perimeter ma? Perimeter, see, perimeter, circumference both are same meaning. When we have a curve, we should use circumference. When we have a closed line segment figure na, we should use a perimeter. Yes, perimeter, which is equal to 2L 2 times B, which is equal to 2 into what you said, L plus B, because L will be coming here, B will be coming here also. Understand? That is what I am telling. Same manner, sometime triangle also will be using. Suppose this is a base B, height if I am giving H na, what is the area of triangle pa? 1 by 2 base into height. These things and all just revise. Suppose equilateral triangle na. Suppose equilateral triangle na. Equilateral triangle area, in the sense what you will say, root 3 divided by 4 into side square. Yeah, a square. If you are taking side is a square or any side. This is 2D. 3D if you are entering na, no, both it will be coming inside. No, don't want to mention, just leave it. Next cylinder if I take, cylinder if I take, curved surface area or lateral surface area, they will be telling. Curved means then there is a curve in a shape, they'll say curved surface area. There is no curve like a cuboid, cube and all, they'll be using lateral surface area. Cylinder means 2 pi r h. Total surface area 2 pi r into h plus r, and volume if you are going na pi r square h. Cylinder shape, you know, if you want you draw, that is h, this will be r. Okay. Next, cone. What is that? Lateral surface area. What is the curved surface area? Lateral surface area pi r l. Here pi r into l plus r. Here 1 by 3 pi r square h. Cone. Okay. Next, sphere. Sphere also we will be using. So sphere na, it will be coming like this. 3D. Okay. Now 4 pi r square. Total surface area we don't have. Sometime we will be using total surface area, same 4 pi r square only. 4 pi by 3 pi r cube. And maximum these things will be using. Hemisphere, half of this will go. Hemisphere rare. Okay, we'll write. Hemisphere rare case we are using. So that will be 2 pi r square, 3 pi r square, volume 2 by 3 pi r cube. Next important things what na? Cube. Cube means all the sides will be having equal length with a box shape. This is side. Suppose if I'm taking A na, what I'm getting? 4a square, 6a square, a cube. Next, cuboid. Cuboid if I'm taking na, cuboid, this I will be taking length, breadth, height, h. So that here what you will be getting pa? Here what you will be getting? 2 times L in, sorry, 2 times h, 2 times h into L plus B. Here 2 into LB plus BH plus HL. This will be L into B into H. So this is basic formulas we need. Suppose apart from this, if it is there anything na, we will be using. Yeah, 4 pi r square. Total surface area actually we are not going to use. Suppose if they ask na, same formula we will be using here. Understand? Total surface area, nothing is there. If they are telling to use total surface area na, we will be using this. And one more thing, in the exam time, total surface area means they will give only surface area also they will give. Just surface area if they mention also, the meaning is total surface area only. Understand? Just surface area if they mention also, the meaning is what? Total surface area only. Have you understand? So this all formula you have to revise. Already you have studied these things in 10th and 11th. One more time you have to revise. We will be using all those things in the sums. Can I go to next pa? Have you done ma? Write faster Raja. Write fast. See here, cylinder and all, right circular cylinder, even cone also right circular. Okay, cylinder also right circular cylinder, cone also right circular cone. Done appa? Shall we go? Right. Okay, appa. Sums will start. What is the sums? Exercise 6.1 we are starting. Exercise 6.1. Find the rate of change of area. Listen carefully. Already we have seen the definition. Rate of change. Listen. Rate of change of what they are mentioning, that is the numerator variable. Rate of change of what they are mentioning here. Rate of change of area. Rate of change of quantity. Na, that quantity we have to differentiate. Listen, stop your work, everybody. First question, listen. So rate of change of area. Na, area we have to differentiate. Very important. What we have to differentiate? Area. So rate of change word, if you have seen, we have to differentiate. Which one you have to differentiate? Next, what they are telling? Area. So rate of change of area means area we have to differentiate. Which area? Next line, circle. Then area of a circle, which is equal to A I am taking, which is equal to pi r square. Okay, with respect to what? That is also they will be giving you continue with respect to its radius r. So that we have to differentiate pi r square with respect to r. Okay, so that differentiate this, what I am getting, differentiate with respect to r. So what I am getting, a, capital A, when I differentiate, dA divided by dr, which is equal to pi is the constant, multiply constant, let it be r square. When you differentiate 2 times r into r, when you differentiate with respect to r, what you will be getting pa? 1. Okay, what you will be getting ma? 1. dr by dr, it will be 1. Okay, right, fine. Next, what they are telling, when r equal to 3, what is the answer? Okay, rate of change of area, when radius equal to 3, what is the answer they are asking? Then you have to continue the simplification. 2 pi r is my answer. What is that? dA by dr equal to, this is my answer in general. At specifically point number A, means subdivision number A, when r equal to 3 centimeter, what is the area of increasing? Means dA divided by dr, what I said, at r equal to 3. This symbol, have you remember? This symbol means what? At. Okay. So that 2 pi into 3, which is equal to what ma? 6 pi r. 2 3s are 6, 6 pi r. This is area, means children, area na centimeter square per. Listen carefully. Area means what? See, here generally they are given centimeter. Centimeter na I am giving centimeter square. Listen. Numerator area means here also numerator must be area. Area means centimeter square. Right. This is rate of change, means per second or per time or per what we have to mention. Per we have, per means in denominator what we have? Radius. Radius also in what measurement? Centimeter. So centimeter square per centimeter you want to mention. Be careful. Okay. Don't think it will cancel. Understand? This is we are mentioning. Speed now we will be mentioning kilometer per hour, right? Like that here, area we have in centimeter square per centimeter. That's it. Like that here 6 pi, sorry, r value we have mentioned now. 2, what is the 2 3s are 6 pi centimeter square per centimeter. That's it. This is for A answer. And B answer na, in same answer number 1 you substitute. Okay, same answer number 1 you substitute. B r is equal to 4 centimeter is given. dr equal to 4 centimeter, then 1 implies dA by dr at r is equal to 4. What is my answer? 2 pi r value 4. Okay, when you simplify this, 8 pi centimeter square per centimeter. That's it. This is our required answer for first one. Is it easy or what? What do you feel? Huh? I said in the introduction x equal to x naught. I said na. Instead of x naught only, they are given here 3 answer. 3 if you substitute, you will be getting like that. I said. Is it okay, pa? Easy only, no? Same model only we are going to do in this whole exercise. Very simple. Just you want to understand the concept how we are starting. Then boy side. What about girl side, pa? Write fast. Those who are done, kindly write next question number 2. Don't waste your time. Okay, I'm going next, pa. Listen, second question what they are given. Let's see. Volume of what is that? Volume of cube. Listen carefully, children. Volume of cube increasing. Listen, increasing means what I said. Increasing means positive. Okay, what is positive? Derivative is positive. So volume of cube. Cube. Okay, cube is a topic. Cube is the topic. Volume of cube means dV by at what we have to see. Here, see, centimeter cube per second. Second means time. Second means what? Time. So dV by dt is equal to increasing na positive 8 centimeter cube per second. Sir, what is given that you write, sir? Read the question. What is given that you write? Okay, volume of cube is increasing at the rate. At the rate means you know dV by dt. How I am writing dV by dt? Listen, volume means dV. T how I gave? T by s. S means time. So dt. Understand? dV by dt. How fast? How fast is the surface area increasing? Surface area increasing. How question is what? How fast surface area? I will take yes. How fast surface area is increasing? Question mark. Sir, S means surface area. S means what, ma? Surface area. How fast surface area increasing when length of the edge is 12. Okay. If A equal to 12 means cube they are mentioning na. Cube edge is given here. Cube edge is given what are Raja? 12 centimeter. Cube edge what is given, ma? 12 centimeter. So we have to find the surface area. Generally surface area is mentioned na. What is meaning I said? Total surface area I said. Generally surface area if they are telling na, the meaning is what? Total surface area I said. Have you remember, children? Have you remember? That is important, pa. Right. Right. So that surface area increasing. How fast surface area increasing is a question mark. So ds by dt we have to find. First surface area. Surface area of a cube. Okay, surface area of a cube. Surface area of cube I am taking yes. What is surface area of cube, ma? What is surface area of cube, Raja? Amma? 6a square. Surface area na total surface area I told to take. So 6a square is our answer. Understand? Right. So that is I am going to take now. So that here you should write that 6a square. Okay. Now we have to differentiate this one with respect to what you will be doing. What is the variable here? T. T. Listen. What is the variable here? T. You should do with respect to T. But listen carefully. The given volume with respect to what they are given? Given volume with respect to what they given? T. So generally what we will think? Function in terms of what variable? Based on that only we have to differentiate. So function in A, so that differentiate with respect to A you will think. It's wrong. So that how you have to what is the find with respect to what now? See the condition which they are given. They are given by t. T means we have to differentiate with respect to time. So that differentiate with respect to t only. Okay, by using the volume only, I'm finding these things. Now differentiate ma. ds divided by dt is equal to 6. Let it be a square when you differentiate 2 times a when you differentiate dA divided by dt. There is a problem. Whether you have dA by dt, whether you have a dA by dt, no. But with help of volume, we can find dA by dt. So in since I am taking in since itself, first volume. What is the volume pa? Volume is equal. Volume of cube what ma? A cube. Now differentiate. Now differentiate with respect to t. This is I am doing in since itself. So that dv divided by dt, which is equal to 3a square. A when you differentiate dA divided by dt. Have you understand? dv by dt we know what pa? 8. dv by dt what do you know ma? 8. So 8 which is equal to 3a square dA divided by dt. I need only this sum, right? I'm right. So remaining you send opposite. It means 8 divided by 3a square is equal to dA divided by dt. Okay. This you take substitute here. This you take substitute here. Then what I am getting? 6 2s are 12a multiply dA by dt. Now only we got with help of volume. What is that? 8 divided by 3 times a square. So when you simplify, what I am getting? 1a 1a cancel. Next 1 3s are 4 3s are cancel. After cancel, what is my remaining ma? 4 8s are what ra? 4 8s are 32. 32 divided by what we have? A. This is what? Surface area. ds divided by dt, which is equal to what? Surface area na? Centimeter square. Listen. Numerator surface area. So centimeter square. What is denominator? T. T means what ma? Yes. Second. Okay. This is our answer at present. But at anything is given that you should use. Listen how fast. At what they given? A equal to 12. What they asked. So that you have to substitute here. That you have to substitute here. So that again ds divided by dt at a is equal to 12, which is equal to 32 divided by 12. When you cancel, what I am getting, you see pa? What table we can use? Shall we use a 4 table? 4 table shall we use? 3 times how many 4? 8. Okay, so what is my answer then finally? Yes, what is my answer finally? 8 divided by 3 centimeter square per second is my answer. That's it. Very simple. Very simple. Listen, see the previous one directly we got an answer, but here extra one portion it was there. Means the previous one what na? It was in R variable. They asked to differentiate in R, so directly we got an answer. Listen carefully. It was in R variable. They asked to differentiate R, so directly we got an answer. Okay. With respect to they mentioned with respect to radius you do like that, they instructed, based on that we got answer. But here what happened, we have a variable in A, but in given they used time. In given they used time. S means time. Second. Then with respect to time only you have to differentiate. So that additionally 1 point we got dA by dt when we do another variable. Same variable if you are doing same variable na, with respect to A if you are doing, you never faced extra point. Directly you would have done this. Okay, be careful whatever we have extra here. Right. Copy this Raja. Second one you copy. Second one you copy. Okay Raja, I hope you understand this everything. Next third question we'll meet in our next video. Take care children. Thank you. See you later. Bye.